not change. Frequency is the ratio between speed and the wavelength. So as the speed decreases, the wavelength should also decrease so that the ratio remain unchanged. Here, what happened in a deep region, the speed, higher speed, so the frequency, longer wavelength should be there so that the ratio will be constant. So remember, whenever wave travel from deep to shallow or shallow to deep, its frequency remain unchanged. Moving from deep to shallow, the speed of the wave will decrease as well as the wavelength will also decrease. So C will be the right answer for this. In question 22, the light travel at a speed of 3 exponent 8 and undergo a refraction as it enters the block. The diagram shows the light ray before and after it enter. So what is the speed of the light in the glass? So to get the speed, the formula which relate the speed and the refractive index, n is equals to c by v. So n, the refractive index, is 3 into 10 power 8 divided by v. Or if we need the speed in the medium, so v is equals to 3 into 10 power 8 divided by n. But we don't have the refractive index, so we have the angle. This one is the angle of incidence and angle of refraction. So whenever light travel from air to glass, the formula for refractive index is sine angle I over sine angle R. So it will be sine 55 divided by sine 33. When we solve, this will come out as 1.5. So refractive index is 1.5. So 3 into 10 power 8 divided by 1.5. So it will be 2 into 10 power 8 meter per second. So B will be the right answer. And even without calculation, I can cancel out the wrong answers because when the light travel from air to glass, so it should slow down. So if in air it was traveling at a 3 into 10 power 8 meter per second, so in glass it cannot travel faster. It should be a smaller speed. In question 23, the diagram shows a narrow beam of a light which is incident in a glass air boundary. So glass is a dense medium, denser medium, and air is a rarer medium or low density medium. And you can see this is the angle of incidence. And what is the angle of refraction? This is a refracted ray. And this one is a reflected ray. So the angle of a refraction is 90. So when the angle of refraction is 90, the angle of incidence is known as the critical angle. When the angle of refraction is 90 and the light is traveling from denser medium to rarer medium. So which row is correct? This is an example of total internal reflection. No. Why no? Because if this was an example of total internal reflection, then there should be no refraction. Like all of the light will reflect, no refraction should occur, but there is a refraction, so it is not an example of total internal reflection. If it was an example of total internal reflection, then how it should appear? It should appear like this. And what about the angle theta? It is critical angle. Yes, it is critical angle because the angle of the incidence is known as the critical angle when the angle of refraction is equals to 90 degrees. So angle of incidence is critical angle when angle of refraction is 90. We simply call that as angle of incidence as a critical angle. So A will be the right answer. When an object is placed in front of a thin converging lens, the diagram shows a path of the two rays. So when we complete this path, the position where the two light rays intersect, that is the position where the image will form. So this is a position where the two light rays intersect, and whenever two light rays will intersect, it means that this image will be a real image. So the image which is formed compared to object, the image will be larger, and real images which are formed by a convex lens are always inverted. So the option it will be large, that is true, and it will be inverted, that is also true, because real images are always inverted. If an object is closer to the lens, image will be away from the lens and it will be larger. If object is away from the lens, image will be closer to the lens and it will be smaller. So it will be a large and inverted image. Then in question 25, a remote controlled vehicle is traveling on the surface of the planet. The vehicle sends obstacle and send the radio message to the control room from where it is being controlled. The control room is 2.4 into 10 power 6 kilometer away from the vehicle. The control room send the message back to the vehicle telling to stop. What is the minimum time elapse between the vehicle sensing the obstacle and receiving the message back from the. So basically how much time, like this is a vehicle and here is a control room. So this message is sent and the message is received. And because it is using a remote control is there, so it is using an electromagnetic radiation. So what is the speed of electromagnetic radiation? That will be 3 into 10 power 8 meter per second. That's a speed. And the distance of from control room to the vehicle, that distance is d, which is 2.4 into 10 power 6. But because it is going and returning back, so the distance it's like a reflection or echo, so that's why the distance will be twice. So we'll use the formula speed is distance over time, but because it bounced back, so the formula will be speed is equals to 2d divided by t. So we need a time lapse. So we need a time. So it will be 2d divided by speed. So 2 multiplied by distance 2.4. But see, this is in kilometer. So we have to convert into meters. So this was in kilometer. We have to convert into meter. Because the speed which we are using in meter per second, that's why the distance should be in meters. So we'll multiply by 1000. So it will become 2.4 into 10 to the power 9 meters. So 2.4 into 10 to the power 9 meter divided by speed, which is 3 into 10 to the power 8 meter per second. So when we divide, it will take about 16 seconds to travel and return back. In question 26, a sound wave is traveling outward from a loudspeaker into a surrounding air. Here are these 3 statements are there. Which statements are correct? Air pressure is lower at a rarefaction compared to compared with undisturbed air. That is true. Rarefaction, the pressure is low. The density of air is less at compression compared to that is wrong, because density of air is more. In a compression, the particles are close to each other, so more particles in a unit space. If the volume decreases, it means the density will increase. But here in the mention, the density is less, so that's why it is wrong. The distance from compression to rarefaction equal to half wavelength. That is true. For example, we have a compression, the region of high pressure, then we have a rarefaction, and then we have a compression. So distance between the two successive compression is called wavelength. But between compression and rarefaction, that will be equal to half of wavelength. So third statement is also correct. That's why 1 and 3 are the correct statements related to sound. Which combination of a material give us shortest time to reach the microphone? So because in solid sound travel faster in solid compared to that in liquid, and liquid it is travel faster compared to that of gas. So if we have like example gas here, gas, hydrogen is also a gas, air is a gas, water is liquid, copper is a solid, aluminum is solid, water is liquid, oil is liquid. So which combination, if we are using a solid sound travel faster, so it will take the shortest time and instantly it will reach from loudspeaker to the microphone. The diagram one shows a small compass needle with its poles marked. It is not near any magnetic material. The diagram two shows a bar magnet with a piece with the poles marked, the compass needle, in which direction it will point. So the direction of a magnetic field is always from north to south. So when we first draw the field line to show a representation of to represent the direction of a magnetic field. So it is from north to south. So this is the direction of the magnetic field. So when we place a compass, if I place compass here, it will point in this manner. If I place at P, it will point towards right hand side. So you can clearly see if I place a compass, it is pointing towards the right hand side. So B will be the right answer. So compass needle always point in the direction of a magnetic field which is from north to south. In question 29, a student rubs a plastic rod with a cloth. The rod becomes positively charged. So if something becomes positively charged, it should lose electron. So it has lost electron or it loses electron. That's why it becomes positive. If it becomes negative charge, then it should gain electron. In question 30, an isolated metal sphere is positively charged. It is then brought near to another isolated. So what will happen? What will the distribution of the charge? This side will be negative and this side will be positive. Equal number we should make. So remember, because in a metal, the positive charges never move. Basically what happened, like example, if there was no charge nearby, so if there was no charge nearby this positive ions, the lattice of a positive ion in the metal, and the delocalized electrons. Electrons are free to move within this structure. But as a result, what happened when we bring a positive charge rod? So electrons, majority of the electrons are shifted towards one side. So if we have majority of electron towards one side, so it appears that most negative on the left hand side and most positive on the right hand side. So when we check, some positive charge move, that is wrong, positive charge never move. Some positive charge move, some positive charge move. So A, B, C are totally wrong. Positive charge does not move, but some negative charges move towards the left or electrons move towards left. So positive ions or positive charge within the metal does not move. They can only vibrate about a fixed position. Which statement about the resistance of metal wire is correct? We know resistance is directly proportional to length and it is inversely proportional to area of the cross section. So directly proportional to length and inversely proportional to area of cross section. That's why B is the right answer. So it's a straightforward question. Thinner wires have high resistance and as well as the longer wires also have high resistance. Question 32. This is a potential divider circuit. The circuit which divides the voltage, we call that as a potential divider circuit. So the voltmeter is there across LDR. For LDR, if we have more light dependent resistor, it will have low resistance or the voltage will also decrease. So which row describe? Basically the circuit diagram shows an LDR potential divider, and which row shows the resistance of LDR and the potential across it at a specific. So if the light level, if the light intensity is high, then the resistance should be low and voltage should also be low. So there's no option. If it is bright, then both should be low and low. But if it is dim, Like if we have low light intensity, then resistance or voltage across LDR should be higher. Resistance of LDR should be high, as well as the voltage should also be higher. So if it is dim, then high Ni, so C will be the right answer. Question 33. Three NAND gates are connected in a single chip as shown. The whole chip behaves as a single logic gate. Which type of logic gate it is acting? So we will check with options, like example, if both inputs are 0. This is a NAND gate. How a NAND gate gives us the result? It is multiplication and invert. Multiplication and invert, multiplication and invert. So 0, 0. So here 0 and 0. 0 multiplied by 0 is 0. And as an inverter, it will give us 1. And here also 0. So 0 multiplied by 0 is 0. As an inverter, 1. 1 multiplied by 1 is 1. As an inverter, it will make 0. So when input 1 is 0, when both inputs are 0, the output is also 0. If one of the input is 1, like any one of them we are taking as 1, so what will be the output here? 1 multiplied by 1 is 1, passes through inverter, make it 0. 0 multiplied by 1 is 0, passes through inverter, make it 1. So it is 1, 0, it will be 1, or we can also say 0, 1, it will also be 1. And then 1, 1, this is 1, 1. 1 multiplied by 1 is 1, passes through inverter, make 0. 0 multiplied by 0 is 0, passes through inverter, make it 1. So which the truth table, this is a truth table for OR gate. So which one? D is the right answer. So basically this combination will act like an OR gate. A solenoid is connected to a very sensitive ammeter. The rod is inserted one end. Ammeter shows a small current. So means that whenever there is a change in magnetic field, that induce EMF. So what should be this rod? This rod should be magnet, because when magnet is moved towards or away, there is a change in magnetic field which induce EMF. So it should be a magnetized steel rod or a permanent magnet. Either when we move the magnet or a solenoid, there will be a change in magnetic field, and that produce EMF, or the needle will deflect. The diagram shows an electric generator with a coil in the vertical position, as you can see. So when the coil is vertical position, the induced EMF will be 0. When it is horizontal, maximum change will be there. That's why the induced EMF will be maximum. And which row describe the generator? So in generator produces what? Generator does not produce it. We convert AC to DC by diodes. So generator always produces AC. And when the voltage will be 0, the voltage is 0 when the coil is exactly vertical. So if the coil is horizontal, the induced EMF will be maximum. And when it is vertical, the induced EMF is minimum. Then we have the primary coil. They mentioned the diagram shows a transformer. There are 460 turns in the primary. So NP is equals to 460. And 24 turns, so NS is equals to 24. Primary voltage or voltage of primary is 230. Voltage of secondary, we don't know. So we'll use a formula Vs over Vp equals Ns over Np. So Vs over Vp, voltage of primary, that is 230. Number of turns of secondary 24, number of turns of primary 460. We cross multiply. So Vs is equals to 24 multiplied by 230 divided by 460. When we simplify, this will be 2 and 12. So it is a step down transformer which reduces the voltage to 12. The charge on a proton is E. What is the charge on electron and what is the charge on neutron? Neutron does not have charge. Electron charge is also E, but the nature is different because protons are positive, so electrons are negative, so D will be the right answer. Then 4 students are asked to comment on the process of nuclear fission and fusion. Their comments are recorded in the table. Which row is correct? Fission and fusion both releases the energy. That is one thing. And fission means breakdown of a large unstable nuclei into lighter nuclei, and fusion means the two lighter nuclei join to form a heavy one. But remember, fission and fusion both releases the energy. So when we check energy absorbed, no. So that is wrong. This is correct for fission, but energy is not absorbed. Two nuclei join, so this is totally wrong. So energy is released in fission and two lighter nuclei join in fusion. That is also correct. And even if it was energy released in fusion, that is also correct because both reactions are exothermic, releases the heat energy. A radon is there, it is emitting out alpha particle, the nuclide which is formed. So when general equation for alpha emission, atomic mass decreased by 4, the nucleon number decreased by 4, and proton number decreases by 2. And as a result, produce a helium nuclei. So it is 219 minus 4. So it will be 215, and 86 minus 2. So this should be 84. So 215 and 84. The last question, the graph shows the activity of a radioactive source over a period. What is the half-life? Half-life means time taken by half of the radioactive sample to decay. So if originally it is 120, half of 120 is 60. So how much time it took to convert into 60? Taking 2 minutes. That's why B is the right answer.